This is lesson 5.1 of accelerated geometry. It's called the Polygon Sum Conjecture. So by the end of this lesson, we would like to have established a formula that would allow us to find out what is the sum of all the angles in a four-sided figure? What is the sum of all the angles in any five-sided figure? What is the sum of all the angles in a six-sided figure, and so on? There's an investigation on page 262 in our textbook, and I would have you do steps 1 through 6 on paper. And when you do that, you'll end up with a conjecture number 31 that you'll be able to add to your conjecture list. And then I'm going to ask you another little question after that, and then we're going to do some sample problems. So instead of you doing the investigation, I'm going to run through that investigation with you. So the first thing I would have you do in your groups is I would have some of you investigate a three-sided figure, some of you investigate a four-sided, a five-sided, a six-sided, a seven-sided, an eight-sided, and then hopefully we're going to come up with an n-sided. So the people with three sides would draw a three-sided figure using a ruler, and then you would measure these three angles, and you would come up with a sum of 180 degrees in those three angles. And then the people who have the number 4 would draw any four-sided figure, measure the four angles in the four-sided figure, add them up, and hopefully come up with 360 degrees as the sum of the four angles of a four-sided figure. 1, 2, 3, 4, 5-sided. When you add up the angles in a five-sided figure, they're 540 degrees. 1, 2, 3, 4, 5, 6-sided figure. When I add up the 6 angles in a hexagon, they turn out to be 720 degrees. 7-sided, 1, 2, 3, 4, 5, 6, 7. So there are 7 angles in there. When you add those up, you will discover that there's 900 degrees. And an 8-sided figure, 1, 2, 3, 4, 5, 6, 7, 8. When I add up the 8 angles in there, they turn out to be 1080. Okay, now the investigation leads you to go back and say, do you notice anything about these numbers? Well, 180 doubled is 360. So if I have, this is 2 times 180, this is 1 times 180, and look at this. This is 3 times 180, this is 4 times 180, 5 times 180, 6 times 180. Okay, now I'm going to think about this. They all have 180, but those numbers in the front change. When I have 3 sides, I use the number 1. When I have 4 sides, I use the number 2. 4 to 2, 3 to 1. 3 minus 2 is 1. 4 minus 2 is 1. Does this pattern continue? 5 minus 2 is 3. 6 minus 2 is 4. 7 minus 2 is 5. 8 minus 2 is 6. Okay, so what do I have here? I take the number of sides that are in the figure, and I subtract 2, and then I multiply that times 180. So I think I have discovered the formula for the sum of the interior angles of any polygon. Now, is there another way I can do this? Let's see. This has 180 degrees in it, so we know that. When I have a four-sided figure, if I start here, look what I can do. I can break it into 2 triangles. These 3 angles are 180. These 3 angles add up to be 180. So therefore, I had the 2 triangles, each of them with 180 degrees in it. Okay, 1, 2, 3, 4, 5-sided figure. What if I start here? I can break the 5-sided figure into 3 triangles. This has 180. This one has a sum of 180. This one has a 180 as a sum. 3 triangles, each with 180 degrees. 1, 2, 3, 4, 5, 6. If I start here, 1, 2, 3 lines create 1, 2, 3, 4 triangles. Each of the 4 triangles has 180 in it. So you see that I'm getting the same pattern as I did when I did that first investigation. 1, 2, 3, 4, 5, 6, 7. If I start here, 1, 2, 3, 4 lines create 1, 2, 3, 4, 5 triangles, each with 180. 1, 2, 3, 4, 5, 6, 7, 8. If I start here, 1, 2, 3, 4, 5 lines create 1, 2, 3, 4, 5, 6 triangles, each with 180. So the number of sides subtract 2 always gives me how many triangles? 7 sides subtract 2 give me 5, 6 sides subtract 2 give me 4, 5 sides subtract 2 give me 3, 4 sides subtract 2 gives me 2, and 3 sides subtract, I don't have to do that one, it's just 180, right? Okay, so what is the rule then? N minus 2 times 180. So that's another way to see it. So if I go now back to my presentation, and I go to the conjecture for this, I think that there is the conjecture. The sum of the measures of the n interior angles of an n-gon is n minus 2 times 180 degrees. So that is conjecture number 31. So you need a sketch for that. 1, 2, 3, 4, 5, let's say. So this would be 5 sides, but 5 minus 2 triangles, each 180 degrees. Okay. Now it says, think about this. If the sum of the measures of the interior angles of any polygon is n minus 2 times 180, what would be the formula you could use to find the measure of one interior angle of an equiangular polygon? If it has all equal angles in it, then this has n minus 2 times 180 degrees in the 4 angles. So this would be 4 minus 2 times 180. And if I want to find one of them, since they're all equal, I would divide by 4. Okay. If I have 1, 2, 3, 4, 5, 6, 7, 8, so this has 8 sides. So this would be 8 minus 2 times 180 for the sum of all of the interior angles. But then I have 8 of them that are all equal. So if I divide that total sum by 8 equal ones, that will give me the sum or the measure of one of the interior angles. So if I go back and change this 4 to an n, and this 4 to an n, and this 8 to an n, and this 8 to an n, I think I have the formula. You can find the measure of each interior angle of an equiangular n-gon by using n minus 2 times 180 over n. So that is conjecture number 33. Now I have just 2 examples. So if I go here, it says how many sides does a polygon have if the sum of its angle measures is 3060. So the sum of the interior angles is n minus 2 times 180. So that's what our conjecture was. they tell me the sum of those interior angles, so I substitute this sum of the interior angles with 3060. Now, I'm going to distribute the 180, so I get 180n minus 360. Next, I'm going to add 360 to this side and 360 to this side, so that this goes away. So I now have 3,420 equals 180n. And then to get the n alone, I'm going to divide both sides by 180. When I do that, n is equal to 19. So notice how I started out with, what are they asking for? The sum of the interior angles. So I used the formula, I put it down, and then I substituted in the stuff I know. I know the sum is 3,060, and so therefore I can use an algebra equation to find the answer. And one more problem. How many sides does a polygon have if each one angle of the polygon measures 160? So the formula I'm going to use for this is that second one that we discovered today. Each one interior angle is n minus 2 times 180 divided by n. So they're telling me each angle is 160. So this gets 160 substituted in for it. Now I have to use some algebra. So I'm going to put a 1 underneath here, and I'm going to cross multiply. So these guys multiplied equal those guys multiplied. So here I am, 160 times n is 160n, and 1 times n minus 2 times 180 is n minus 2 times 180. Distribute the 180 to the n and to the negative 2. I have n's on both sides, so I'll subtract 180n from this side and subtract 180n from that side. So negative 20n is now negative 360, and now divide by a negative 20 on both sides, and I have n is equal to 18. So those are the two conjectures for section 5.1 and a couple of examples to help get you through.